on. All right, participants, thank you very much for joining. Today is the 25th training day on Stata, and we have covered a lot on on these sessions. In the last session, we have basically covered the multinomial logistic regression, and today we are going to discuss the ordered logistic regression, how it is used, what is the specific detail of ordered logistic regression, and how it is implemented using Stata. So let us go straight forward to this model. It will start from slide 48. So what is basically the ordered logistic regression and how it is different from other forms of logistic regression? Ordered logistic regression, it is also known as ordinal logistic regression. It is a statistical method used for modeling the relationship between one or more independent variable and an ordinal dependent variable. So when your dependent variable is basically ordinal, it means it is showing some order from highest to lowest or from lowest to highest, or it is showing some rank, then we are going to use the ordered logistic regression. Always remember that in case of ordered logistic regression, there are more than two outcomes here. There are more than two basically outcomes here because in case of simple logistic regression, there are two outcomes. The binary logistic regression, especially there is 0 and 1 coding. But in case of ordered logistic regression, there is a ranking of the order of the given order from highest to lowest or from lowest to highest or something like this. So an ordinal variable is one that has distinct order categories, but the interval between the categories may not be equal. For example, consider a survey where respondents are asked to rate a product on the scale of poor, fair, good, and excellent. So you can see that poor is the lowest order, while excellent is the highest order. So whenever your dependent variable is basically representing some order, some rank from highest to lowest or from lowest to highest, that means you are going to use the ordered logistic regression. So the responses are ordinal because they have the natural order: poor, less than fair, less than good, less than excellent. But the difference between poor and fair may not be same as the difference between good and excellent. Obviously, the difference may not be equal because they are showing some rank. So, in case of ordinal logistic regression or ordered logistic regression, it is used to model the probability that an observation falls into one of the categories or threshold of the ordinal dependent variable based on the values of independent variable. There is a question from Vakar. OLR are independent variable are ordinal. Yes, some of the independent variable are also ordinal. I will discuss with you the specific detail, the file that I have shared with you. I will discuss the specific detail of each variable when I will describe the set of variable that we will be using in our data set. So don't worry about it. So it estimates the relationship between independent variable and the cumulative odds of being in a certain category or below it using a logistic function. The model assumes that the log odd of being in or below each category compared to the categories above it are a linear function of the independent variable. It also assumes proportional odds, meaning that the effect of independent variable on the odds of being in a particular category is consistent across all categories. So your dependent variable is showing some order or some rank, while your independent variable may be continuous, they may be ordinal, they may be ranking, they may be binary. But always remember that your model is based on your dependent variable, which is ordinal dependent variable. So here are some examples in order to understand more critically what the model will look like and what would be the specific examples that will deal with ordered logistic regression. For example, here is the example one. A marketing research firm wants to investigate what factors influence the size of soda. So basically, the size of soda is the dependent variable. So here, if you can see, the dependent variable is represented by small size of soda, medium size of soda, large size of soda, or extra large size of soda. So the dependent variable is showing some ranking, some order from small to extra large. So that is why ordered logistic regression is used. In case of other factors, these are the independent variable. They may be continuous, they may be binary, they may be ordered also. So always remember your model is based on dependent variable. That is why we are going to use the ordered logistic regression. So these factors may include what type of sandwich is ordered, burger or chicken, that is your independent variable, whether or not fries are also ordered, and age of the consumer. So these are your independent variable, like what type of sandwich is being ordered, whether the fries are ordered or not, what is the age of the consumer. So these are your independent variable, while your dependent variable is the size of soda, which is showing some ranking. So while the outcome variable size of soda is obviously ordered, the difference between the various sizes is not consistent. The difference between small and medium is 10 ounces, between medium and large is 8, and between between large and extra large is 12 ounces. So the difference is not also equal. The difference between different sizes is different for all levels. So this is the some of the detailed of ordered logistic regression using example one. So let us also discuss the example two. A researcher is interested in what factor influence modeling in Olympic swimming. Relevant predictors include at training hours, diet, age, and popularity of swimming in the athlete's home country. So these are basically the independent variable. The independent variable includes training hours, diet, age, and popularity of swimming in the athlete's home country. The researcher believes that the distance between gold and silver is larger than the distance between silver and bronze. So basically, uh, you are going to discuss the impact of these independent variable on different types of medaling, whether it is gold, whether it is silver or bronze medal. So they are basically different from each other. The silver medal is better than the gold medal is basically better than silver, and silver is better than bronze. So there is some rank, there is some order in terms of your dependent variable, which is medaling. So in this case, we are going to use the ordered logistic regression. Then there is another example that is based on ordered logistic regression. As an example three, a study looks at factors that influence the decision of whether to apply to graduate school. So you are going to discuss the factors that may influence about your decision whether you are going to apply to a graduate school or not. So college junior are asked if they are unlikely somewhat likely or very likely to apply to graduate school. So this is your dependent variable, unlikely, somewhat likely, or very likely. These are three scales. So unlikely is represented by 0, somewhat likely represented by 1, and very likely represented by 2. So these are some order, some rank, which is attached to your dependent variable. That is why we are going to use the ordered logistic regression. So hence our outcome variable has three categories: data on parental education status, whether the undergraduate institution is public or private, and current GPA is also collected. So these are your independent variables. The researcher have reason to believe that the distance between these 3 points are not equal. For example, the distance between unlikely and somewhat likely may be shorter than the distance between somewhat likely and very likely. So the distance between these scales are not equal. It is believed, it is assumed here. So these are the specific examples relevant to ordered logistic, and I hope that you have understand the ordered logistic regression conceptually. Now we are going to deal with some data. I have shared a data file with the name ordinary logistic regression OLR file with both of my participants. This is basically a hypothetical data set that has three-level variable called apply. So in this data set, apply is basically the dependent variable which is coded by 0, 1, and 2 that we will use as a outcome variable. We will have three variables that we will use as a predictor, like PARED, which is basically indicated by 0 and 1, variable indicating whether at least one parent has graduate degree or not. So if at least one parent has graduate degree, it is indicated by 1. But if none of the parent has graduate degree, then we will indicate it by 0. So this is independent variable. This is the first independent variable, which is parent education, pay red. The next independent variable is public, which is indicated by 0 and 1, where 1 indicates that the undergraduate institution is public and 0 means private. And the third independent variable is GPA, which is the student grade point average. So these are three independent variable, and this is the dependent variable, which is showing some ranking, some order from 0 to 2. So let us start with the descriptive statistic. And before that, we need to open the file here so that we may be able to apply the procedure. So let me open the Stata file. And please open the file that I have shared with you with the title OLR. So I am going to open the file with the title OLR that I have shared with both of the participants. If you see here, there are four variables. The first variable is apply, which is dependent variable. The second education is parent, which is parent education. It is an independent variable. Then another variable is public, which indicates whether you are going to get admission in a public university or a private university, then the student GPA. So these three are independent variable, and this one is dependent variable. First of all, we need to apply some descriptive statistic. For example, I need to check what kind of coding here is with the dependent variable. So I need to write here a tab and then write the name of my variable, and it will show me what kind of coding it is being applied. So there are three types of categories here for apply variable. It is unlikely, somewhat likely, and very likely. So there are 220 students who are unlikely to apply in a particular institution, and it accounts for 55% approximately. There are 140 students who are somewhat going to apply in a particular institution. uh, and there are 40 students who are very likely to apply. So these includes only 10%. So this is the specific detail of the tab apply. You can also consider these three categories with their labels or without their labels. So I can write here tab apply, comma, no label. So it will be shown with with their coding. Like unlikely is coded by 0, somewhat likely is coded by 1, and very likely is coded by 2. So it is up to you how you would like to show the specific detail or specific descriptive detail of your data. The next thing that you need to see is tab apply parent education. So I can write here tab apply parent education is pay red. So enter and you will see the results like this. Now it is showing that 200 people who are unlikely to apply have the parents who have no any graduate degree, have both the parents who have no undergraduate degree, while 20 students who are going to who are unlikely to apply for admission have at least one parent, whether it may be father or mother, that have at least an undergraduate degree. Then there are 110 people who are going to somewhat likely to apply, but they do not have both of their parents having the graduate degree, but there are 30 people who are somewhat likely to apply, and from their parents, at least one of their parents have graduate degree. Then there are 27 people who are very likely to apply, but both of their parents have no graduate degree. But there are 13 people who are very likely to apply, and at least one of their parents have the graduate degree. So one indicates here that one of the parents have at least graduate degree, while 0 indicates that none of the parents have graduate degree. So this is some critical detail. Then tab apply public. We can write here tab, then apply, then public. And we can see here there are 189 people who are unlikely to apply in private institute, and there are 31 people who are unlikely to apply in the public institutions. There are 124 people who are not going to apply in private institution. Here you need to understand that 0 means private and 1 means public. So 124 students are somewhat likely to apply in private institutes, and 16 students are somewhat likely to apply in public institutes. In the same way, 30 students are very likely to apply in private institutes, and 10 students are very likely to apply in public institutes. So this is how you can apply the descriptives. You can also summarize the GPA of student. You need to write sum and then GPA. It will let you know what is the specific detail of a grade point average. There are 400 students. The average GPA is 2.99. It is approximately 3 GPA. The minimum GPA is 1.9 and the maximum is 4. So this is the specific detail of the GPA that you are going to consider here. Now, we are going to watch the ordered logistic regression, and before we are going to apply it, we need to understand some specific detail about our data. Below, we use the ordered logistic command to estimate an ordered logistic regression model. The I before parent education indicates that parent education is a factor variable, because we already know that parent education has two categories. So it is a factor variable. In the same way, you can see that public is also a factor variable. So you need to place I before all of your factor independent variable, while you don't need to place any I before your continuous variable. So GPA is your continuous variable, while parent education and public is the factor variable. So this is the model. You need to write here O logic, which is ordinary logic. Then you need to place dependent variable. Then you need to place the independent variable. For example, if we consider that all are continuous variables, then the model will look like this. And after running the model, it will show the results like this. So you can see here the log ratio is 24.18 and it is statistically significant. Your R square is approximately 3.2%. The parent education is positive and statistically significant with your dependent variable. Your public institution is negatively influencing, but it is not statistically significant. Then GPS score is also positively influencing your likelihood to apply, and it is statistically significant. But if we consider this particular code with the factor variable, like parent education is a factor variable, public is also a factor variable, we can run like this. Now this command look like this. So this is yes. You can see here the R square is similar. The probability greater than chi-square is also similar. The parent education is statistically significant. The public is also negatively influenced, but it is not statistically significant. The GPA is statistically significant. So this is the specific detail that you can apply here. So what we need to do, first of all, we need to interpret our results. So these are the interpretation that you need to understand. At iteration 0, Stata fits our null model. We have already discussed it that iteration process basically displays how many times the data is basically iterated on a given model. So it can be used as a comparison with nested model, which is not required. Our model is statistically fit because the log likelihood ratio chi-square is 24.18 with a p-value which is less than 0.05, and R square is approximately 3.26. It means your independent variable are explaining the variation in your dependent variable approximately 3.2%. So in the table, we see the coefficient, their standard error, the z-test, and their associated p-values, and 95% confidence interval of the coefficient. So both parent education and GPA are statistically significant. uh, you can verify it, but public is not statistically significant. So for paired, we would say that for 1 unit increase in parent education, going from 0 to 1, we expect a 1.05 increase in the log odd of being in high level of apply, given all of the other variable in the model are held constant. So this is the particular way to interpreting your results. So we can interpret it again. A 1 unit increase in parent education, which is going from 0 to 1. 0 means that both of the parents are not graduate, while 1 means that at least one of the parents are educated. So when we increase 1 unit from 0 to 1 in the parent education, we expect a 1.05 increase in the log odd. That is the specific word that you are going to use with this particular type of estimation. So we expect a 1.05 increase in the log odd of being in the higher level of apply, because we have three levels of apply: unlikely, somewhat likely, and very likely. So we are considering here the very likely. So we expect a 1.05 increase in the log odds of being in the higher level of apply, given all the other variable in the model are held constant. So for 1 unit increase in GPA, we would expect a 0.62 increase in the log odds of being in the higher level of apply, given all the other variables in the models are held constant. So this is the particular way of interpreting or ordinal logistic regression. Then we need to understand the odd ratios. First of all, I need to run the odd ratios here. What I need to do, I need to run the similar model. I need to increase here comma and then OR. It will display as the odd ratio instead of the coefficient values. It will show us the odd ratios here. So in place of your coefficient values, you will see the odd ratios. So if you can see here, the odd ratios which are given, you need to interpret also these odd ratios. So how to interpret these odd ratio? For parent education, we would say that for 1 unit increase in parent education, going from 0 to 1, the odd of high apply versus the combined middle and low categories are 2.85 greater, given that all of the other variable in the model are held constant. So this is basically the odd of applying in the higher category of that institution from 0 to 1 as a parent education. So if you see here, let me show you. If you see here, this is the odd ratio. It means if you consider 1 unit increase in your parent education from 0 to 1, there is a 2.85 chance. It is basically more than double the chance of applying in the higher category or in the higher category of application in that particular institute. And this is 94% chance. This is approximately double the chance based on the GPA. So your GPA and your parent education will increase the chances of being acceptance in the higher category of a particular institution as a part of the application procedure. So let me discuss from here the interpretation. So likewise, the odd of combined middle and high categories versus low apply is 2.85 times greater, given that all the other variables in the model are held constant. For a 1 unit increase in GPA, the odd of high category of apply versus the low middle categories of apply is are 1.85 times greater, given that the other variable in the model are held constant. Because of the proportional odd assumptions, the same increase is 1.85 times is found between low apply and the combined categories of the middle and high apply. The next thing that you need to understand is basically you can create further list of your analysis. You can also use the list coefficient command to obtain the odd ratios as well as change in the odds for a standard deviation of the variable. We have used to help option to get the list in the bottom of the output explaining each variable. So list COEF comma help. So we can copy from here rather than typing the command, or we can type it list COEF comma help. It is unrecognized SSC install list COEF. So it will install the command and SSC install not found at SSC type search list coefficients. Let us search the command. I need to see from where it It need to be installed. Instant coefficient, all right. Command for post estimation. Regression model for categorical outcome. I think this one would be much better. Let us install it. Click here to install. Just wait for a couple of seconds. Whenever it is installed, we can use it. It's taking some time, and we need to wait for a couple of seconds more. It is taking too much time. Let's try to run it again from the main window. It is showing the percentage of completeness here. So let's just wait. If you can see the bottom left side, it is showing some percentage of the commands being completed. So let's wait for a couple of seconds more. It is taking time. Right. Let us run this command from here. If it is run, it is okay. Then we can proceed with it. The command list coefficient is not recognized. So we need to wait for this command to run it. So it will indicate both of these commands you can use with. This is the end of discussion. This is just an additional part that you can apply with. I will share the slides and you will estimate these two also. So this is the odd ratio is the main command, and the ordered logistic model is the main command that is being used for ordered logistic. So today we have discussed the ordered logistic. The remaining is probate logistic that we will cover in the next session. That is probably going to be executed on Monday. So do you have any question, both of the participants? Please let me know for today. All right, I think message has came. No, sir. Oh, all right. So I will share these slides and the remaining part with you. And till then, we will meet on Monday with the remaining part. And thank you very much for joining and stay blessed.